So, good evening. I welcome you all for the week 8 lecture interaction session on subsurface exploration, importance and techniques involved. So, this week we are going to see about the dynamic testing carried on pipe. So we all know about the pile foundation. Okay, so pile foundation is a deep foundation which is done for mostly heavy load is transferred, or when the substrata is not going to have a very good bearing capacity, we go for a pile foundation. So whenever we construct a pile, okay, whether in a pile construction there are two different methods, like driven pile or cast in situ pile. So in driven pile we make the pile factory made, and we hit the pile and drop it and insert it into the soil. And in board cast in situ pile, we usually drill a borehole, insert a casing, then we insert the reinforcement cage, and we pour the concrete into it. So here in cast in situ pile, the pile is made at the site, whereas in a driven pile, the pile is made at factory, and it is just like we hit a nail in a wall. Okay, so this pile is hit inside or dropped inside the soil. So whenever we have a pile foundation, uh, nor the surrounding soil gets disturbed. Okay, so there will be a ground heave, there is a soil displacement to the sides, and also there is excess pore water pressure developed when we are having a clay type of stratum. So in general there will be disturbance to the soil. And also when we cast pile at site, okay, like this, where we insert the cage and we pour the concrete from the top, there are a lot of lot of situations where the concrete will not be perfectly set. Okay, so both in both in driven pile and cast in situ pile, we need to ensure at the field whether the whatever the designed length has been attained, and the whether the calculated load bearing capacity of the pile is going to be as we designed. Okay, so we need to check at site. So it is very important to conduct pile testing, dynamic pile testing, um, which is going to be a non-destructive testing. So here you can see the possible, I will also show what are the other possible, but here we can see that there are sometimes where your concrete is not properly formed around your reinforcement cage. Okay, these are the defective piles that has been formed at the site. Okay, so when you are going to have such kind of defective piles, it is the load bearing capacity will be not as what we calculated. So dynamic testing of piles, we have two types. One is going to be high strain, and the another one is going to be low strain. So in high strain test, what we do is we have strain transducers and accelerometers fitted to the pile, and we have a pile head, and above that pile head we will have a hammer system which will drop or hit, give impact force on the pile, and it will cause the pile to uh, move down into the soil. So this high strain test means once we hit with such a large heavy weight hammer. Okay, so that because of the impact load, the pile just gets penetrated into the soil. We while penetrating, we have to make sure we have to check whether the stresses that is being developed in the pile is going to be what we have calculated. Okay, so the two things are there. The stresses that is caused while the hammer is dropping should not even cause a destruction to the pile, and also when it is being inserted, it should not cause a reduction to the bearing capacity of the soil because of the disturbance or because of the stresses that is being created due to the impact load. So this dynamic test, that the high strain test, is mainly to find out the stresses that is created. That is the first thing. Okay. Whereas low strain test, it is meant for whether we have made the cross section correctly, whether there is any defect in the pile. That thing we can find out from the low strain. So in a high strain test, so the driving of pile is going to cause you disturbance to the surrounding soil, so it can alter the actual soil structure. Initially when we calculate the pile capacity, okay, so we just calculate what could be the property of the soil, like we find out what are the shear strength parameters like phi and psi, and we see what is the cross section of the pile, and that way we have a formula to find out how the pile capacity. But when it comes to the site, once you start installation, automatically the soil gets displaced and the properties are going to be altered. So whatever we are calculated in the design in paper is not going to be the same that in the field. That we have to check, cross check. Okay, so this way the actual resistance the soil offers to the pile load might be different from the one determined from the in situ investigation. So once you finish driving your pile and you're going to apply the load, okay, because of the changes that has occurred to the surrounding soil, the pile is not going to give you, or because of the changes that has occurred in the pile itself because of stresses created during the driving, okay, the pile is not going to give the same strength. That is what we calculated. We are going to check it whether it can give or not, but we have to check whether the stresses that are developed are going to be within the allowable limits. So the objective of the in situ test is to determine the actual stresses which are going to be developed in the soil as well as the pile while driving. This will also ensure the above stresses should not exceed the bearing capacity of the material. Both the soil and the strength of the material should not be exceeded. So the skin friction and toe resistance in case of frictional and end bearing pile deciding the actual pile capacity casted in situ. That is, the pile is going to carry the load because of the resistance offered by the tip if it is going to be end bearing pile, and because of the resistance offered at the sides because of if it is a frictional pile. Okay, so we have to calculate both the values in the in situ condition. So you can see here, so this is your pile which is projected upwards, and it's a pile head, and above which you have going to have a hammer hitting, and we have sensors that is connected, acceleration sensor and the strain transducer. So this test, it is called as high strain dynamic test, and this test is generally conducted for 5 to 10% of the total number of piles in general. So if you are going to have 100 piles, around 5 to 10 piles will be subjected to the test. It can be done both on driven and board pile. So we have two strain sensors and one acceleration sensor that is fitted on the top. I mean, fitted on the pile. So the sensors which are bolted on the periphery when the pile is at surface. So the sensor should lie at 1.5 times the D from top and ensuring the safety of the sensors against the hammering action. So at hammering, to drive the pile in the soil, so when we drive the pile in the soil, the sensors detect each impact in the analog format and transfer it through the digital signal. So once the impact comes, it will detect the uh, impact force and it will give you as digital signal. So this also known as pile driving analyzer. So as I said, while driving the pile also we can while the pile is driven also it can used, and also for board piles, that is even after the pile is cast in situ, for that type of pile also we can use. So this is how your pile driving analyzer looks like. Okay, so we have a graph kind of a digital signal. So what could be the output? As I said, pile load carrying capacity. We would have calculated the pile load carrying capacity from the soil properties and the cross section, as I said. But once you install your pile, or especially in case of board cast in situ, you are not sure about the cross section whether it has formed perfectly. So the output are going to be the pile load carrying capacity. So it will give you what could be the load carrying capacity, both in terms of end bearing and skin friction, and the stresses developed in the pile during the driving operation, and if there is going to be any displacement of the pile. See, your pile has to be perfectly vertical, but because of certain site condition, the pile would not gone vertical. It could have hit a rock or something. I can show you once again. What happens is, if we have, this is our borehole. Okay, so this is a ground area. So if we are going to have some big rock kind of thing which we are not aware, okay, so once we install our pile, what could happen is the pile can hit and it can go in sideway, especially if you have a soft deposit. Okay, so it can, while we keep on driving the pile, so there are possibility that the pile can go in sideway, so there's displacement of the pile we can detect. So blow counts in order to stop the driving operation and the minimum depth of installation. So interpretation. So how do we interpret the results? So the sensors that will give you the impact of the force applied, whereas the acceleration sensors are going to determine the propagation velocity against the hammer impact. So as we give the hammer impact, the strain sensors will measure how much force has come, whereas acceleration sensor will give you the propagation velocity. So by solving an wave propagation equation, okay, so we'll be able to find out what could be the resistance that is could be offered by the pile. So depending upon the nature of resistance provided to the pile, sensors will detect the direct waves as well as the reflected waves, giving the indication of the collective resistance. So once we hit, the force is going to be measured by the sensors, and the waves that is being generated, it will be measured by the acceleration sensors. So there will be both direct and reflected waves that will be traveled into the material of the pile. Okay, so that will be measured. So measuring the resistance, that way we get the resistance that is offered by the pile, will be able to calculate what could be the total resistance. So we have an equation. So once we know what could be the force and velocity values, when we substitute in this equation, we will be able to find out what could be the total resistance offered. Okay. Okay, so the various different types of defects that could happen in a pile, one is going to be inclusions. If it is going to be, there could be any other unwanted material if present, cracks. This is, we are going to see about low strain test. So we have seen about high strain test. And just one second. So we have seen about the high strain test now. Okay, so your high strain test can give you ultimately the stresses developed and the load carrying capacity of the pile. Now, if you want to check whether the pile has formed the required shape, that is, whether your pile is going to be intact, if there is going to be any cracks that is going to be present in the pile, all such things we can get from a low strain test. So your low strain, the large strain dynamic test is to determine the stresses developed during the hammer. I request everyone to mute yourself when you are logging in. Okay. So in our large strain test, we'll be able to determine what could be the ultimate load carrying capacity of the pile, what could be the stresses that is developed in the pile when the pile is penetrates the soil, all such things. Whereas in a low strain test, we are ensuring whether the pile has formed without any defects, whether it is going to, because it is formed below the ground, we are not able to visually see if it is a bored pile. Whereas in a driven pile, of course we'll be able to see the pile. Okay, it will be factory made, the pile is like made, ready made, factory made, we'll be able to see any defects or thing. But whereas in a bored pile where you insert a reinforcement cage and you are pouring concrete from the top, so there, in such case, you won't be sure whether the concrete has covered all the reinforcements, whether there is going to be any issues. Once you pour concrete, there will be segregation, honeycomb formations, and all. So, in order to ensure whether the pile has formed as in an intact manner, we are going to do some low strain test. So, to understand the pile has cross section and length as per design, so whether it has attained or occurred the length what we need, and whether it has occurred the proper cross section that we have calculated. See, this is like once you have this only, it will be giving you the load carrying capacity. That is the result of the high strain test. Okay, so this is like very very important. So to detect the defects, if any present, like necking, honeycombing, segregation, cracks, arching. So these are the various issues that we may face when we cast a pile at site like this. So there could be some cracks or any joint formations, improper diameters like bulging or necking, we call this as necking, or there could be even when it passes through different layers, and sometimes material changes material when we go for a composite pile. Okay, so we'll be able to know at which depth we have, up to which depth we need a steel pile, and after which depth we are going to have a concreting, so whether it has formed as per that design. Okay, so in a low strain test, sometimes in a low strain test we will not be able to detect a few defects, like when there is a gradual increase or gradual decrease in your diameter if your pile is casted in such a manner. Pratap, ready, do you want to say something? Pratap, ready? No. Then uh, please mute yourself. Okay, I have muted. Again, don't unmute. Okay. So even by doing low strain test, we may not be able to detect certain defects. Like if you are going to have a curved formed pile, or any minor inclusions, minor foreign material, or a smaller loss of soil that is present around. Okay, so local loss of cover or local loss of surrounding soil that is in a very smaller fraction. And if the debris is going to be present at the bottom of borehole, so we need a borehole to construct our pile. So if it is not properly cleaned at the bottom, that defects, if it is going to be present, this will obviously affect the load carrying capacity of the pile, especially your end bearing capacity. Okay, so these defects we will not be able to find out from our low strain test. That's the limitation. Okay, so these are another different types in like necking, as I said, necking and major defect. It's like major defect means there is going to be a joint, improper joint, and this is going to be bulging. These are like major defects, and the whatever which I said is also some rarely occurs. So this we call this break as weeping piles, where and sometimes you can see soil gets comes in between your concrete, because surrounding you have, if you have a loose deposit, the soil may come in between, so your concrete is not properly formed here. This is going to be your concrete itself become displaced because of improper casing, or because of loose deposit or improper pouring of concrete. Your reinforcement is here and your concrete has been cast like this. So we have two types of test in low strain test, that is going to be sonic logging, and the other one is going to be pile integrity test. We have two types of test. So in sonic logging, we have pipes, that is a main difference. Whereas we need, while casting the pile, we have to insert some PVC pipes Okay, for our receiver and your transmitter. So these are going to be your PVC pipes that are inserted into the uh, reinforcement cage, and the concrete is poured around. Okay, so after the test, what they will do is they will seal this pipes also with your grouting. So institute method to study any possible defects in strength, in terms of strength variation in the pile material. So, being cheaper, the test is possible in almost every pile that is cast inside. That is the main thing. This is not suitable for your driven pile. Okay, while casting the pile itself, we will be inserting the pipes. So, it will detect any anomaly which are possible defects in terms of acoustic irregularities along the pile length. If you can see, this pipe is inserted throughout the pile length. Okay, so throughout the pile length, these PVC pipes will be inserted, and these are PVC pipes, and this is your reinforcement cage. So along the entire length, we will be able to detect any defects if present. So two probes, one emitter and other receiver, are lowered each into the hollow space of the PVC pipes. So I'll show you one more picture. Here you can see, so this is going to be your transmitter, and this is going to be your receiver. Sometimes in a different configuration, we can have one emitter and different around the in a circular form we can have different receivers. So it's up to us how do we keep it. So this is going it is going to give you a signal. Okay, so if it is going to be received by the receiver without if there is going to be any defect, you'll be having a clean curve. Whereas when there is going to be any defect, like you can see, if there is going to be any cavity being formed, any such thing, then our graph will be showing a variation. So from that we will be able to find out, okay, that particular depth there is going to be any issue. So both the tubes are first filled with water. That is the first step. So we cannot insert our receiver and transmitter in a empty tube. So we are going to fill all these pipes with water. Both the emitter and receiver are lowered into each tube till they reach the bottom. So we are going to find out from the bottom to top how the signal is being transferred. So not like from top to bottom, so it will first reach the bottom, and from the bottom we slowly pull the receiver and the transmitter slowly at various depth. We will be able to find out how the pile quality is. So the emitter generates sonic waves propagating in all directions. Some of the waves are detected by the receiver in the other tube. So, based on your arrival time and distance between the emitter and the receiver, you will calculate the sonic wave velocity. So, we will know what is the distance between the pipes. We will know what is the time taken for the sonic wave to reach from here to one, from one pipe to another. So that way we will be able to calculate what is the sonic wave velocity. So yes, from the there are some reference values. If your sonic wave velocity is going to be around 3,700 meter per second, then it means that it is going to have a very good concrete formation. And if it is going to be decreased or increased, means then there is going to be any issue. So the wave velocity in water is going to be 1,500 meter per second, and the lowest is going to be in air in 300 meter per second. So we will repeat the test at various depths. So we'll slowly pull this up. You can see a pulley arrangement. So from the once reaching the bottom, we'll slowly pull this up, and we will measure the wave velocities at different depth. So this also pulled up simultaneously. From the sonic logging profile that shows your wave velocity versus depth. Okay, so we'll be able to know what is the quality of concrete at every depth. So once if there is going to be any defect, as I said, in segregation, whether the concrete is not properly poured in that area, properly formed or in that area, we'll have some deflection in the uh, graph. That way we'll be able to understand that in that area there's some issue is there. So profiling can be done either in the form of travel time versus depth or wave velocity versus depth. Your delay in travel time, that will give you an indication of change in concrete quality. And this is a codal provision ASTM D67002. 676002 provides a guidelines for the setup. Okay, so just make a note of it. This code gives you how to conduct the test. So once before conducting the test, we have to make sure few things. That is, this is if this is going to be your PVC pipe, the bond between the concrete and the PVC pipe should be perfect. Okay, so sometimes what they do is even they make this PVC pipes rougher surface in order to have a very good bond. If it is going to have a smooth surface, the bonding is not going to be that much perfect. So your PVC pipes should be very well bonded with the surrounding concrete, and minimum one tube per foot, and should be purely vertical. So you have to see that all the tubes should be parallel to each other also. A cover is like even when we do our reinforced casting for our slab beam, we give a cover. Okay, so like for foundation it is 75 cover. We keep cover blocks in order to ensure that that much thick your reinforcement is covered with your concrete. So we for PVC pipe you have to provide a minimum cover of 3 inch in your reinforcement cage. Once the concreting is done around the tube, it is filled with water so that ensuring no loosening of bond between the concrete and tube. So your pipe shouldn't go any changes in shape because of setting of concrete. Okay, so it will be filled with water. Once the test is over, water should be removed and the tube should be grouted. So after finishing our test, the water will be removed and all the tubes will be grouted with your cement grout. So at least we have to give some 24 hours gap between your curing and finishing concrete. Since the test requires continuous power supply, we have to ensure that there is a continuous power supply. Any knots in this cable should be removed in order to have a proper reading. So depending on the findings, so if you find any defect in our pipe, depending on the findings, we can accept or reject, or we can perform few more tests in order to confirm the result also. So this is the typical field record from your sonic logging test. So you can see a number of signals, that is because you have five receivers. So all your five receivers are giving some signals, but at a particular depth, when you are going to have any defect in concrete, there is going to be difference in the signal. And along the depth, we'll be measuring what is the quality of the concrete. Okay, so in sonic logging we saw that we have to use some PVC pipes during the formation of the concrete itself. But whereas in pile integrity test, we no need to do any um arrangement like this. This pile integrity test can be conducted on finished piles. Okay, so you no need to give any special arrangement. So you have a hammer and you have a analoger. So this again we are going to find out the concrete quality and the pile cross section and length, the same as objective of the sonic logging. It does not require any tubing while casting the concrete as done in our CSL. So field setup consists of attaching the acceleration sensors to the finished pile. So we are fixing the sensors to the finished pile at the top, and will give impact by the means of this hammer. Okay, so there are two different types of hammer also available depending on the need. So we give the impact by this hammer. So this this acceleration sensor will measure or will find the will detect the reflected wave that is hit from at the bottom and gets reflected back. So once a wave is generated at the top, it goes and hit the bottom and comes to the sensor. Okay, so it will measure what is the time taken. So we'll know what is the time taken, that way we'll measure what is the velocity. So in order to set up the hammer impact and acceleration sensor, there are some guidelines. For example, especially when you're going to have a circular pile, okay, I will just tell for a circular pile alone. So this is your acceleration sensor, and this is the point where you are going to hit the hammer. So this distance should be at least d by 4. Okay, so d is your diameter of the pile. So this arrangement is for diameter of pile lesser than zero point 0.6 meter. Okay, so if your pile dia is lesser than zero point 0.6 meter, then you can go for this guideline, that is where your distance between your acceleration sensor and hammer impact should be less, should be d by 4. Whereas when your dia is going to be greater than zero point 0.6 meter, then this is how you have to arrange the sensors and the hammer impact location. So to get the velocity time history from the acceleration sensor record. So upon hammer impact, waves will travel between the pile head and toe with a velocity which is a function of concrete quality. So that is the main thing. So your wave travel, it will hit the bottom of the pile and it will come back to the top. So depending on the concrete quality, we will be able to measure uh, how this time will be recorded. So depending on the concrete quality, we'll be able to get a difference in the time. So signature of the reflected wave will help you in understanding the medium characteristics. So there are standard published signature records. We can keep it as a reference. Okay, so that reference will help you whether our pile has undergone any changes in cross section or any defect is there. Sharp reflection is an indication of impedance contrast, that is change in material pile section properties. So you can see here, as I said, some reference as I said. So this is your pile section. Okay, so your reflectogram will give you a graph like this. So you'll be able to analyze that. Okay, then the pile is straight and the length what we needed is present. If there is going to be a shorter length of the pile, then our graph will look like this. Then we will understand, okay, the pile is not cast to the required depth. If there is going to be any cross section difference in the pile below your ground, so your reflective graph will be like this. So we can understand from that there is a difference in the cross section at a particular depth. And once if your pile is going to have any irregular shape, okay, so you will have a graph like this. So it will show you that the pile is not at all properly cast, it is having a very irregular shape. So you have to decide about it. So the test is done to ensure the pile is meeting the design requirement. We are casting the pile at site. Okay, so below ground, anything can happen. There could be some soft deposits around which would have caved in. So the pile section would have increased because we are pumping the concrete until the concrete comes to the surface. Okay, so the concrete would have squeezed to the sides, and sometimes because of your closer reinforcement spacing, the concrete would have not properly formed. Okay, so you have to see whether you have given the proper cover. So something is happening below the ground where we are not visually able to see it. So this pile integrity test will help you whether the formation of that concrete pile is going to be intact and it is formed for the required length, whether it is going to formed of in a proper diameter, etc. So we are going to test, it is kind of a trial and error. Once if it's not properly formed, then we have to see what is the issue there, or we have to go for a redesign, such things. Or it is about the soil, or it is about the proper improper workability of the concrete also. Okay, so if the quality of the concrete is poor means that also can cause you issue to the formation of your pile. So in case of any sharp reflection is there, then the pile can be accepted. That is, in case of weak signal is there means we have to decide whether to accept or reject the pile. And in case of sufficient reflections from intermediate depths, the pile is reject. If you get many reflections, then it means that throughout the length of the pile there is going to be improper cross section. So limitations, as I said in the initial itself, there are certain limitations with this pile integrity test. That is, as we cannot find if it is a curved pile. We cannot find if the cross section increases gradually or decreases gradually. So the test detects the defects based on change in impedance, that is like a resistance. Okay, so if there is going to be smaller resistance offered because of any foreign material present in a very small amount, then it is not, will not be able to capture it. And if we will not be able to differentiate between the resistance because of pile cross section or concrete quality, both will give you a deflection in the graph. Even if the pile cross section is not proper also, we'll get some deflection. And even if the concrete quality is poor also, we will get some deflection. So sometimes we will not be able to differentiate whether because of what this deflection has caused. And the impedance is also a collective effect of pile and soil properties, and thus it is difficult to identify the reason. As I said, if your surrounding soil is not going to be intact, or if it's not going to very good, uh, then quality, then also there could be some graph influence in your graph. Sometimes we will not be able to judge whether because of the pile or soil it is that kind of anomaly is coming. So defects identifiable using our pile integrity test. We can find cracks, if there is going to be any joint, change in cross section, major change in material properties, and as I said, we won't be able to detect curved piles and removal of or loss of material, etc. We'll see some previous assignment questions. So the velocity of particle motion against impact load through a pile as per Timoshenko. So Timoshenko has given a velocity equation, velocity of particle equation based on the impact force. So V of t is Ca by E, F of t. F of t is your force, C is your propagation velocity through the medium, and E is Young's modulus. And V of t equal to C by Ea into F of t, or V of t is C by rho F of t. So the answer is going to be B, that is V of t equal to C by Ea. This is the answer. C is your propagation velocity divided by your Young's modulus and area of cross section. Pile driving analyzer test. As I said, pile driving analyzer, whether it going to be a high strain or a low strain. So pile driving, we are going to drive the pile. Okay, obviously the force that you are going to apply is going to be very very large. Okay, so it is going to be a high strain dynamic test. Which of the following are examples of low strain dynamic test in pile? As I said, low strain dynamic test are going to be two types. That is going to be your sonic logging and pile integrity test. So the answer is going to be B and C. In case of skin friction offered by intermediate layer along the pile shaft at a particular distance from the pile head, the nature of upward traveling and downward traveling resistance waves. So when you're going to have a pile driving analyzer test, okay, so if you are going to have intermediate layer, and the once the intermediate layer is present, there are going to be two types of waves generated. One is the compression waves and the tension waves. Okay, so the compression waves will be traveling in the upward direction, and the tension waves will be traveling in the downward direction. So the answer is going to be that. That is what they're asking. The nature of upward traveling and downward traveling waves are going to be: upward is compression, downward is going to be tension. In case of freestanding pile, the signal after dash reflection will be very weak to be considered. See, when we are going to record, we'll be able to record up to two. That is, first impact load travels, the wave travel, hit the bottom, come to the top, and again it will hit the top and come to the bottom. At least up to second reflection we will be able to travel. After that the waves become weak. Okay, so the signal becomes weak. So up to second reflection we will be able to measure. In a pile integrity test that is formed on a circular pile of diameter zero point 0.4 meter, what would be the minimum distance between the hammer impact and acceleration sensor? So if you remember, I have shown you a this is going to be a circular pile. Okay, so here you are going to have the acceleration sensor, and here is going to be your hammer impact point. So for a D that is going to be lesser than zero point 0.6 diameter, up to D lesser than zero point 0.6 diameter, this distance is going to be D by 4. Okay, so here the diameter is going to be zero point 0.4 meter. So the distance between your acceleration sensor and your hammer impact point should be D by 4. So D by 4 is going to be zero point 0.1 meter. Okay, fine. So with this we have come to the end of your dynamic testing on piles. Okay, so dynamic testing on piles, there is a high strain test and a low strain test. High strain tests are mainly focusing on the load carrying capacity of the pile, and the stresses that is being generated while the pile is driven into the soil. Okay, so that is the main focus of high strain test. Whereas in low strain test, we'll be able to find out whether the cross section of the pile is perfect as per our design. There is a main motive in a low strain test. Okay, we use a very low force. That is the main thing. We are not hitting with a very big hammer and all, just a small hammer. Okay, so in low strain test we have two types, like sonic logging and pile integrity test. Okay, I'll just summarize the modules we have gone through from the week 1 to week 8. So initial in first class we have seen about what are the need and objective of the subsurface exploration. So why do we need to do, or why do we need to do a soil testing or a soil collection, in situ testing? Okay, what is the purpose? And so only if we do soil testing we will be able to know what choice of foundation we could choose. Soil is a natural material, it could have lot of surprises when we start our construction. Okay, so it is very very important we have to know what lies below the ground, where we are not visually able to see, whether it's a rocky stratum or a soil stratum, it's a weathered rock, or you have any pipelines running below, utility lines, anything could be lying below, or it could be a abandoned well. Okay, uh, some years ago there would be a well, then now it would have been put off debris and it is closed and they would sell you. Okay, so we have to know what is lying below our ground, and then only we'll be able to know what kind of foundation we can go, and what could be the alternate methods if the soil is going to be poor. What could be the alternate methods, foundation or ground improvement we can use. Any forensic investigation, whether if it is going to be any uh, site where the structure has fallen. Okay, already some accidents has happened, a bridge would have uh, demolished or something. Okay, so we can do any forensic investigation also. And in order to have a overall success of the project, in order to ensure the overall safety of your structure, you have to do the soil testing. So even in Noida recently they have demolished apartment, because as per the guidelines they have not constructed. Okay, so we no need to have, we don't want such issues later. And also the safety of adjoining structure, while we construct, the adjoining structure may get cracks or anything, so settlement, so we have to ensure that safety also. So all these, in order to have a very pre-planning of our site. Okay, so we have to do a site investigation. In module 2 we saw what are the various possibilities to do a site investigation, whether we can go for trial pit or we have to drill a borehole and collect the sample. Okay, then if it is a sample collection, whether it's going to be a disturbed sample or undisturbed sample, it depends on the purpose, whether we have to do if you're going for a power plant construction, Obviously we need a undisturbed sample. We have to be very sure where our power plant comes. The settlement should not be there. Okay, so groundwater table, presence of it and its any variations, and rock samples, and the various institute tests like vein shear, standard penetration, cone penetration, diatometer, pressure meter. So we saw how we saw some problems solved in order to find out the pressure meter modulus and the diatometer modulus, etc. Then in module 3, we saw about geophysical investigation. So these are all institute tests. We are drilling and we are doing some destruction to the area and we are finding. We cannot do for the entire site. If you want to do for the entire site, we can go for the geophysical investigation. That is, which is going to be a non-destructive testing. So we've seen about the various advantages and limitations and various different types like seismic reflection survey, refraction survey, electrical resistivity, surface wave methods like MASW, and magnetic survey, gravity survey. These are the various geophysical tests. Then in module 4, it is about offshore investigation. So in offshore, how to collect sample. We saw some technical, some basics, very basic of anchors, different types of anchors, and how an offshore profiling is being done by bathymetry survey, sonar, echo sounding, and how they collect samplers, how the vessel is various different components of a vessel. Then in our module 5, in last module, we saw about dynamic testing of piles. Okay. I thank you all for your patient listening. If you have any doubts and clarifications, you can ask me. You have any doubts? This is our last class. I thank you all for attending. If you have, I will soon upload the week 2, which has no audio. I have soon I will upload by today. Um, do you want to have a kind of a problem revision session before your exam? Just some numericals to be solved. Yes. If you want to have any problem solving session, I can arrange for a interaction session. We can solve the problems especially related to SPT, pressure meter, diameter, and all. I have given even a Excel in the drive, in the folder drive. If you want, you can use that Excel for pressure meter calculation and all. If you have any doubts, I can see in chat messages. So, ma'am, you said the distance between the acceleration of sensor and hammer impact is d by 4 for d lesser than 6. Then what about d greater than 6? Actually, there is no formula for that. Okay, they have just given the at center you will have a hammer impact, and surround at equal distances from the center in a triangle formation you can have the um acceleration sensor. Okay, so there is no specific formula for that. Okay, then I thank you all for your